All right, guys, let's take a look at some multi-step inequalities. And let's see here, on one of these, we're going to end up having to use our little trick, I call it, where we have to flip the symbol when we multiply or divide each side of an inequality by a negative number. So we'll get an example of that. And let's see, we also got some distributive property and combining like terms, and really just taking a look at how we get the variable by itself with inequalities, and we'll also take a look at graphing with the open circle, closed circle, which way to point the arrow on the number line. So let's go ahead and take a look here. All right. So I like to treat solving inequalities a lot like equations because they are very, very similar. They just don't have equal signs, right? Inequalities have inequality symbols instead of equal signs, but really other than that, they're pretty much a lot the same. So with inequalities and equations, the very first thing I like to look for is I like to see if we can combine any like terms the way the original inequality is written. So if we scan through here, I'm not seeing any scenario where we could combine like terms where anything sits. So we got this -2 being multiplied here by this quantity. So multiplication and division are kind of like glue. So this quantity and this -2 are glued together here by multiplication into this one big term. So this is one big variable term right here. We got a constant over here, and we got a variable term here. By the way, that's a 1, -1y. So it looks like we're gonna have to use some distributive property here. So we gotta take this big clump that's glued together, and we can send this -2 through by multiplying. And what that's gonna do is that's gonna release this glue right here, and it's gonna turn this big clump of a term into its individual terms. It's gonna split it up. So let's go ahead and do that. That way we can use those individual terms and combine some like terms and sort some stuff out here. So let's go ahead and do that. So -2 times positive 5y, that's going to give us a -10y. And then we got -2 times a -12, that's going to give us a positive 24. Go ahead and bring down everything we haven't used yet. Minus, so we still got greater than, we got a 6 minus, I'm going to go ahead and call that a 1y just because I like to do that. Okay. And looks like we got some like terms that need to be combined, but they have to get on the same side of the inequality before we can combine them. Okay, so I like to get my variable terms to the left in most situations. So let's go ahead and do that. So I got this variable term here, which is like this variable term here. I'm going to get them both to the left side of the inequality. Of course, this symbol splits the inequality into a left side. Here's my right side. So this variable term is already on the left side of the inequality. Let's go ahead and inverse operation this one, right? So let's add 1y to this side of the inequality, which is going to cancel that one out. -1y plus 1y goes to 0. But if we add 1y to this side, we have to go ahead and add 1y to this side. And that's how we get these together over here. Let's go ahead and do that. So we still got our greater than symbol. We got a calculation here, -10 plus 1. That's going to give us a -9. And they're y's, right? So -9y's. We still got our plus 24, and we still got our positive 6. Okay, these two terms are alike. They're like terms. They're both constants. So since I got my variable terms to the left, let's get my constants over here to the right. So let's go ahead and get rid of him here. So this side of the inequality is adding 24. Let's undo that by subtracting 24. Cancels that. But I got to subtract 24 from this side, and that brings these two together so that they can be combined. So now I can go ahead and take positive 6 minus 24, which is going to give me a -18. Still got my symbol. We still got -9y over here. All right, we get to our final step here. We've got all of our like terms combined. I've got my variable term on the left, my constant on the right. My last step is to get my variable by itself. So that y is attached, glued to a -9 by multiplication. So if I want to get that y by itself, I have to unglue, right? I have to undo that multiplication, so I have to do the opposite, which is divide by -9. Multiplying by -9 cancels out with dividing by -9, right? So they both go away. If I divide that side by -9, I got to divide this side by -9. And be careful, here's where a lot of people mess up here. We forget anytime you multiply or divide each side of an inequality by a negative number, right, which we just did right here, we divided each side by a negative number. Just because of that, we have to flip the symbol. Okay, so in my next step, I've got to go ahead and reverse that greater than to a less than. Everything else stays the same. Y is on the left. We do that calculation just like it says, negative 18 divided by negative 9. That's going to give us a positive 2. And there we go. That's a good solution. We can go ahead and graph from that. Our variable is on the left, which is good. I always want my variable on the left side before I graph. That way my arrow will match the direction of my symbol. So let's see, we got 0, maybe 1, 2, 3, something like that. It's ugly 3, sorry. We got open circle on the 2, and arrow points to the left. So y can be any number in the world as long as it is less than 2. All right, there we go. Let's try another one. Got some more distributive property here. Let's take a look. So scan through here. Can we combine any like terms the way it's written right now? I don't believe so. We've got a 29. There's a constant. Here's a constant. Okay, these two guys are like terms, but they need to be on the same side before they can be combined. This negative 2 is attached, glued to this quantity by multiplication. So there's a big variable term right there glued together. In order to split that up into its individual terms, I'm going to have to send that negative 2 through using the distributive property. So let's go ahead and do that. Okay, so I'm going to go ahead and carry this 29 down. That 29 is not a part of the distributive property, so we're just going to carry it down. Okay, that negative sign goes with the 2, right? Negative 2 times positive 3, right? He's a little positive 3. That's going to negative times positive. That's going to give me a negative 6. Okay, then we got negative 2 times a negative 5x. That's going to give me a positive 10x. And then greater than or equal to 13. All right, and it looks like we got some like terms we can go ahead and combine, right? On the left side of this inequality here, left side of the symbol, we've got these two constants. We can go ahead and combine those. I can go ahead and take 29 minus 6, which is going to give me a positive 23. Okay, I'm going to scoot this up a little bit. And then we still got plus 10x greater than or equal to 13. All right, let's see here. I only got one variable term here. He's on the left, and I've got these two constants now that need to be combined. So let's go ahead and subtract 23 from this side. Gone. Got to subtract 23 from this side. Creates a calculation. I got to take 13 minus 23, which is going to give me a negative 10. So we've got our symbol the same. And we still got 10x on that side. And we're almost there. We've got all of our like terms combined. Okay, we just need to get that x by itself. That x is glued to that 10 by multiplication. In order to unglue that, I have to do the opposite of multiplication. So I need to divide by exactly what we want to get rid of, which is a positive 10. So I divide each side by a positive 10. So we do not need to flip our symbol because we multiplied or divided. We divided in this case, but the rule is the same with multiplication or division. We divided by a positive 10, right? So symbol stays the same. 10's cancel. X by itself. We got negative 10 divided by positive 10 gives me a negative 1. So there we go. X can equal any number in the world as long as it is greater than or equal to negative 1. Let's go ahead and graph that. Get a quick number line. I like to show 0 and a negative number. So it's going to be to the left of 0, negative 1. We could show another number if we wanted to. Going to be closed circle, right? Since we got the or equal to sign, it's going to be closed circle. And since our variable is on the left, right, our arrow will always match the direction of our symbol pointing to the right. Fold our arrow to the right. This means x can equal any number in the world as long as it is greater than negative 1. So there you go. There's a couple of examples using multi-step inequalities. We did our little trick on the first problem up here when we divided by a negative. Where's it at? Right here. Okay, we got to flip our symbol anytime we multiply or divide by a negative. So there you go. Hope this helps.